2.6b, related rates. Evan's going to read for us. Here we go.
A 5-foot ladder leaning against a wall slips so that its base moves away from the wall at a rate of 2 feet per second. How fast will the top of the ladder be moving down the wall when the base is 4 feet from the wall?
All right, this is awesome. Let's draw a picture. Let's see what's going on. All right, so we got our wall, we got our ladder leaning up against the wall. How big is our ladder? 5 feet. All right, fantastic. Now, it's leaning up against the wall that it slips so its base moves away from the wall at 2 feet per second. Now, it just makes sense. I call this one X, I call this one Y, and I call this one Z. So what does this mean when it slips away from the wall at 2 feet per second? What did that give me? dx dt is equal to what? 2. Why is it 2 and not negative 2? It's moving away from the wall. My X is getting bigger. Okay? All right, let's keep going. How fast will the top of the ladder be moving down the wall when the base is 4 feet from the wall? So, what am I trying to solve for? dy dt is what I'm trying to solve for. So that's my question mark. And what else was given to me? X is equal to 4. Exactly. All right. What kind of triangle did this make with the wall? A right triangle. Exactly. So what do we know with that right triangle thing? Pythag. So now I have x squared plus y squared is equal to z squared. All right. So let's take a derivative. What's my derivative? 2x dx dt plus 2y dy dt is equal to 2z dz dt. Now, what would I highly suggest you do? Get rid of all your 2's. Get rid of all of them. All right. So now let's substitute in. Let's see how far we can go. What's my x? 4. What's my dx dt? 2. Plus, what's my y? My y is 3. How did we get it? It's a Pythag triple. All right. 4 squared plus what squared will give me 5 squared. All right. So we get 3 for my y. Now, what's my dy dt? I don't know. That's what I'm solving for. And then is equal to, what is my z? 5. What is my dz dt? 0. Tell me why. The ladder's not changing its length. All right. Wouldn't that be such a cool problem if it did? All right. That would be weird. I agree. All right. But the ladder's not changing its length, so that's why dz dt is equal to 0. Pretty good? All right, let's solve. So 4 times 2 is 8, and I'm going to move that thing over there. So I'd end up with negative 8 over 3 is equal to dy dt. All right. Now, why is it negative? It's moving down the wall. Now, I've seen this a couple times on the AP exam. What was the question being asked? And this is kind of rude, but what's the question being asked? How fast will the top of the ladder be moving down the wall? It's already telling me it's moving down the wall. So how fast is it actually moving down the wall? 8/3 feet per second. I need another reader who likes to drive a boat. That looks like Skipper. Go for it.
A boat passes a fixed buoy at 9 a.m. heading due west at 3 miles per hour. Another boat passes the same buoy at 10 a.m. heading due north at 5 miles per hour. How fast is the distance between the boats changing at noon?
All right, fantastic. So we're going to draw a buoy. Thank you for actually saying that correctly, because I've had people in the past say like buoy. So anyway. All right, so a boat passes a buoy at 9 a.m. heading due west at 3 miles per hour. So my little boat A is going this way. It's going this way. All right, there's my little boat. Little boat. All right. And I'm going to call that my x distance. And so if it's my x distance, what was given to me?
Negative 3 miles per hour.
dx dt is what? Is equal to 3. It's positive 3 because my x is getting bigger. It's moving away from my buoy. All right. And then I got another boat passing my buoy. And it's going which way? It's going north. All right, it's going north. And so there's my boat. All right. And this is my y, just because I think that that's my vertical distance. And so what was given to me? dy dt is equal to 5. And so what's being asked? How fast is the distance between the boats changing at noon? And so my distance between my boats is that. So that's my z. But what's being asked? dz dt. Oh, snap. What did we just create? A right triangle again. All right. So what are we going to use? The VAG. So now you have x squared plus y squared is equal to z squared. And what are we going to take? A derivative. So what's the derivative of x squared? Plus is equal to. All right. Again, what would I cancel out? All my 2's. All right. So let's start substituting in and see how far we can get. What's my x? What's my x? Oh, it passes my buoy. So it passes the buoy at 9 a.m. And then at time noon is how far we're at. So how far did it travel?
9 miles.
It traveled 9 miles. Because it was going 3 miles per hour for how many hours? 3 hours. All right, so it's traveled 9 miles. Let's do that same thing. It passed the buoy going north at 10 a.m. and it's going 5 miles per hour. So what's my y? 10. All right. Now, is this a Pythag triple? No. So we're going to have to do a little bit of math. So now we'd have 9 squared plus 10 squared is equal to z squared. 9 squared is 81 plus 10 squared is 100. So then we end up with 181. And then what are we going to do to it? We're going to square root it. So z is equal to the square root of 181. All right, now let's start substituting in and see how far we can get. So what's my x? 9. So now I have 9 times, what's my dx dt? 3. Plus, what's my y? 10 times 5 is equal to, what's my z? Square root of 181. And then I have dz dt. All right. So here we go. 9 times 3 is? 27 plus what? 50. So we end up with 77. So now we have 77 over square root of 181 is equal to dz dt. All right. All right, we need another reader. We need another reader who has a shadow.
Hopefully all of us.
Josiah, go for it.
Suppose a 6 foot tall person.
Are you 6 foot?
No.
Close?
Like 2 inches.
All right, you can wear heels. All right, go ahead.
Alright. 12 feet away from an 18-foot lamppost. If the person is moving away from the lamppost at a rate of 2 feet per second, at what rate is the length of the shadow changing? At what rate is the tip of the shadow changing?
Oh, this is fun. This is fun. All right, let's draw a picture. Let's draw a picture. So, how tall is Josiah with heels? All right. All right, so Josiah is 6 foot. All right, and then how far away is he from the lamppost?
12 feet.
He is 12 feet. So we got 12 feet going on. And how big is my lamppost? 18 feet. All right. Now, if the person is moving away from the lamppost at a rate of 2 feet per second, what is the length of the shadow changing? So I'm going to call this my shadow. And so I'm going to call it S. And so what's being asked? Find the rate of the length of the shadow changing. So how do I notate that? That is ds dt. Exactly. So ds dt question mark. And if that's my S, I'm going to call this my X. So, is he moving away or towards my lamppost? He's moving away. So, if he's moving at a rate of 2 feet per second, that would be what? Dx dt is equal to what? 2. Why is it positive 2 here? X is getting greater. All right. And so if you were moving towards the lamppost, it would be what? Negative. Now, I'm going to keep the recording going. If I have students that get caught up on this, they're like, Mr. Flick, I don't know if that's dx dt or ds dt because that's my person. He's in between them. Totally agree with you. However, if I'm going to be asked a question about my shadow changing, that has to be ds dt. Does that make sense? And so this part is changing as well. That is my dx dt. That is my person moving. You following me? All right. So by process of elimination is how I honestly think about it. Okay. So anyway, there we go. Now let's do it. Well, what kind of triangle things did I just come up with? Well, yeah, they're right triangles. True that. But how many did I come up with? I came up with 2 of them. So let's go back to geometry. What can I make? A proportion. Very good. All right. So I got this smaller triangle right there, and then I got my bigger triangle right there. All right. So let's do our proportion. So I'd have S over 6 is equal to, what is this portion? S plus X over 18. All right. Do you see how we made our proportion? No. So this side over 6, and then this side over 18. All right. However, we can't use 12 yet because we're going to be taking derivatives soon. So how do we solve? Cross multiply. Let's try cross multiply. So now we end up with 18s is equal to 6s plus 6x. I personally would subtract 6s. So now we have 12s is equal to 6x. Now guess what? We're going to take a derivative. No, not substitute in. That won't get us anywhere. So now we're going to take a derivative. So now we end up with 12 ds dt is equal to 6 dx dt. All right. So what is ds dt? I don't know. That's what we're solving for. What is dx dt? 2. So now I end up having 6 times 2, which is 12, is equal to 12 ds dt. And so what is ds dt? 1. So ds dt is equal to 1 foot per second. All right. So his shadow with heels on is changing at 1 foot per second when he's walking away from the lamp like that. All right. Pretty nifty. All right. Now the hard one. What's the last part, TJ?
Last part, at what rate of the length? At what rate is the tip of the shadow changing?
Is the tip of the shadow changing. And the tip of the shadow is that little bit right there. And that has to deal with this whole side. That has to deal with that whole side. And I'm going to call it Z. I'm going to call it Z. You can't solve for the tip until you solve for the shadow changing. Okay? So that's why it's kind of like you have to do it second. So it makes another proportion. So now I'd still have this S over 6 is equal to Z over 18. So again, how do we solve? Cross multiply. So now I'd have 18S is equal to 6Z. Now we're going to take derivatives. All right. So what is the derivative of 18S? 18 ds dt is equal to 6 dz dt. All right. And so, what is ds dt? 1. So I'm going to take that and I'm going to substitute it right there. So now I have 18 times 1 and then divide it by 6. So my dz dt is equal to 3. So the very tip of the shadow is changing at 3 feet per second. All right, pretty nifty. All right. You have a related rates worksheet that Nolan printed, I think. Nolan, did you print them? All right, pass them out, Nolan, pass them out. All right.